Good evening, everyone, and welcome to another episode of Saturday Series. The topic of today's session is 5G changing the landscape of communication. Today, we have with us Dr. Gandhiraj R, Assistant Professor, Department of ECE, Amrita School of Engineering, with us to deliver the session. Before we start the session, students, please note that if you have any queries or questions during the session, please type it in the chat box. We will be addressing all your questions at the end of the session. Now, without further ado, I would like to welcome Gandhiraj sir to deliver the session.
Yes, thank you, madam. So very good evening to one and all present here. So I'm here to share some knowledge based on a communication technologies on 5G under the title 5G Changing Landscape of Communication. I'm dedicating this presentation to all my gurus and my family, Almighty and Mother Nation. Guru Brahma, Guru Vishnu, Guru Devo, Maheshwaraha, Guru Sakshat, Parabrahmam Dasmai Shri Guruve Namah. I'm here because of them. The overview of this presentation is evolution of cellular services from 1G to 5G, global research on 5G and beyond, applications of 5G and what all the facilities are available in Amrita. By joining in Amrita, in what are the areas you can work on based on the expertise in the hardware, software, and the guidance by different professors. And what are the job openings are available. Before that, I wish to share some quotes. Katrathu kaiman alavu, kalladadu ulagalavu. It's written by Tamil poet Avayar. So what we know, the known is very small, unknown is ocean. So this is the meaning of that. So whatever things we know here is very limited, we need to expand. And another quote told by Thirukural, Thiruvalluvar, தொட்டனை தோறும் மணற்கேணி மாந்தர்க்கு கற்றனை தோறும் அறிவு. What we gained when we start sharing to others, it will grow. So keeping this in mind with good quotes, I will start for today's session. Some of the reference materials which I want to share to all of you. These informations are available in this textbooks. The 5G physical layer, since I am from the background of electronics and communication engineering, some of the reference materials I have selected based on 5G physical layer and what all the researches we can procure or we can process and we can proceed more on this area of 5G plus 5G and beyond. So one is the 5G physical layer, principles, models and technology components. The another book is from GSM to LTE Advanced Pro and 5G. This is the second book by Martin Sauter. The third book is the role of a software defined radio. There is a key word is called software defined radio. So 5G is a combination of SDR, software defined radio, and software defined networking, SDN. So this book is actually talks about the research on SDR based the receivers for 5G. The another book is on signal processing techniques for 5G. Why we are moving from 4G to 5G? So we may require a lot of facilities which is not available, especially in the case of the speed, the throughput, and the delay. So these are all the three key factors. To overcome this, to get the level of a 5G facilities, we need to make a lot of signal processing based implementations which is to be realized in a hardware. So this book talks about that. All these things can be realized by using the algorithmical perspective, and we can be realized also. And another important book which I want to share to all of you is that Software Defined Radio for Engineers by Travis and Collins. So with this introduction of the reference materials, so some of the key points which I want to share to all of you, because these are all the very, very important key points we must be aware when we talk about a 5G, when the technical presentation is concerned. I'm not going to talk about all those things here because that is separately can be dealt in the separated technical sessions. Now here I'm going to give you the outline of 5G, how the 5G can be helpful for us in forthcoming period. Now we are in the era of, especially in India, 4G, LTE, Vivo LTE. When the 5G comes, how to utilize the 5G for a layman level? For a business people, how they can convert into a business form? For academical students, how they can convert that into the new innovative products or projects. So the research is almost saturated in the sense to create a new technologies for a 5G. Almost major work has been done, but still the research is going on, but the amount of the growth rate may be relatively, we need to add delta by delta. So if you want to do a lot of research on 6G beyond 5G, we must have idea on 5G. Without that, we cannot move further. So some of the key terminologies which will be helpful, those who are really in the domain of communication, maybe by assuming that the audience majorly they are +2, and those who are interested to join into a engineering domain, especially ECE or computational engineering or any other computer programming, whatever. Nowadays there is no focus. Depends on our interest, we can choose. But this 5G which connect everything. So the knowledge base of individual departments combining all together. So we can establish the communication system which follows the protocols of 5G. Even that is also possible in our lab facilities. Currently, some of the setup has been made in the Bangalore campus. Even in a Coimbatore campus, we have established the hardware facilities for creating our own 5G communication systems. So to do all those, some of the keywords which you are seeing here, the 3D channel modeling, massive MIMO, full dimension MIMO, 3D MIMO, 3D beamforming. You just will keep this word in your mind. So for forthcoming discussion, all these things may be helpful. The concept which I am talking here are the signal processing techniques. Because of these signal processing technique only, the 5G has come. Now we are going to enjoy some of the domain. The other countries already they have established the 5G network is available. Okay. Filtered OFDM, universal filtered multi-carrier, spectrally efficient frequency division multiplexing, FTN, multi-user shared access, sparse code multiple access, NOMA, non-orthogonal multiple access. And some of the other key terminologies focused on 5G is these three. EMBB, Enhanced Mobile Broadband. URLLC, Ultra Reliable Low Latency Communications. So if you visualize the 5G communication, it will come under these three categories. Especially in the case of EMBB, it is meant for mobile cellular communication. Ultra reliable low latency communication, where communication delay should be very, very minimum for that particular specific applications. Massive machine type communication, especially for the case of IoT based communications. To the layman level, we can understand this is for mobile, this is for vehicular communication, this is for IoT. Now, you can see the same thing what I have explained there. It is written in terms of graphically. Enhanced mobile broadband, massive IoT, ultra reliable low latency. If you see here, enhanced mobile broadband, the security camera, for example, security camera, the latency will be 50 milliseconds. In the ultra reliable low latency, especially in the case of the motion control in an industry, if something happens, especially for the case of the vehicle, autonomous vehicle, once some opposite object is being detected, immediately the inside vehicle, the control mechanism has to be responded within a delay of 1 millisecond. So the currently available, even in a 4G LTE, it won't have that much. The latency, the response time, less than 1 milliseconds. We don't have it. So we need it when we are expecting for autonomous vehicles. So if it is coming in future, the 5G will help to realize the same. And another important domain is called massive IoT. IoT, Internet of Things. Each and every of our mobile phone, when the 5G has come, even every devices, electrical devices at our home, electronic gadgets, whichever we are having, everything can be connected. At each home, we may have multiple devices. All devices can be connected. Just will imagine, even in India, the total population itself, 130, approximately 125 crores. So even 50%, you just will imagine, if everybody start utilizing the mobile devices and it is producing the huge amount of data, how all these data can be communicated through a wireless communication system. So the massive amount of data will be produced. Now, the job opening market is here. How to establish once the 5G market is coming to the India, immediately, even lot of job openings are currently is being posted in the very famous job portals. I will show you at the end. So people, those who have a knowledge base on IoT, to realize implement the IoT, we may require the programming knowledge, very fundamental programming language. Even without programming also nowadays things are there. By using a MIT tool is called a Scratch. The Scratch can be used to create a IoT, simple IoT applications. Even school kids can do that. Then, but if you want to do a lot of innovations, creating application professionally, you may depend on some of the programming tools. So you must have an idea on your programming side. In addition to that, you need to have a hardware facility, hardware knowledge base. So you need to choose the domain according to your interest. This is called about a massive IoT. Once the data is being selected, assume that all the data is being pumped or stored in somewhere. In terms of a TB of data will be available in the huge data centers. If we want to do any analysis on that, so for that we may require the data analytics. Computational engineering will be very much helpful for that. That is on one side. The another one is called enhanced mobile broadband, EMBB. So like our normal cellular communication system, how we do a communication using a voice. The major advantage of this mobile broadband is that the mobile can on the move. It can, that's why it's called a mobile. So that can move in a different scenario. The environmental may be a different. Still, we need to ensure that that much amount of a data rate and a communication provisions also has to be ensured. And if the vehicles are moving very fast, what type of the communication channel has to be established? And all these arrangement has been made in the 5G. So the technology, the standards have been incorporating all the issues with the solutions, and the standard has the different releases also. The currently around release 18 to my knowledge, 17, 18. And like ultra reliable low latency, which already I told, especially for the autonomous vehicle, a car without driver. Okay. Like tech inventions for 5G. What are the key technologies actually is being utilized here? One is called scalable. The scalable OFDM, orthogonal frequency division multiplexing. So this orthogonal frequency division multiplexing, already it is available in Wi-Fi, but it has some limitations. How to utilize that concept of OFDM for the variable applications. So 5G is going to be utilized, which already I told in the previous slide, is massive IoT where the data rate is very low. This ultra reliable low latency, which requires which may have the data rate relatively low, but the response time should be very less. And mobile data communication, we will be on the move. The data rate may be relatively high. So all the three different dimensional applications are there. So by having a single fixed OFDM, it won't be helpful. So that's why the scalable OFDM is the first key point. The second one is the flexible slot based framework. So this is a little bit technical. So I want to say that the low latency URLLC forward compatibility, like for different applications which I was talking here, a same hardware, whenever it is inside, for example, take our 5G mobile phone, if you are having in your hand, that same mobile phone can be utilized for the case of IoT. When it is in mode of IoT, which may not be having a capacity to transfer the data at very high speed. Even temperature measurement at home, AC controlling, we need not to sense the information at a high data rate, may not. So at that time, there must be some flexibility in the overall architecture of the 5G. If it is running on the mode of IoT, then automatically it has to reduce the data rate speed. Because of that adaptability, the data rate will come down. The throughput also can be reduced. At the same time, we can save a lot of energy from the battery. Same mobile phone, when it start moving away in the car or in a train, maximum of 70 or 90, 100 km per hour. At that time, the same mobile phone has to be switched into the other mode. So that's called the flexibility in the slot base. For that, they have made some arrangements in these slots. And another important point, which is corresponds to the physical layer concepts, advanced channel coding schemes. Very important channel coding scheme, LDPC, low density parity check, and CRC aided polar codings. So these are all the coding schemes. It's channel coding is nothing but when I am communicating some information through a wireless communication channel. I assume that I am transmitting 3 bits. I will receive the another 3 bits at the other end. But transmitted information, received information, both won't be exactly same. I need to have some mechanism before transmission, do a channel coding at the receiver after receiving corrupted information, because the channel is wireless. That corrupted signal at the receiver can be decoded perfectly. Because of that only we can ensure the communication is successful. So all these things are very, very important. Third key terminology, key techniques which is used in the 5G. The fourth one is that massive MIMO. Massive MIMO. Hope all you have seen a base station. In the base station, you might have seen that a small towers like this. On that, you can see this is the antenna. You might have seen antenna. It may be a one small bar like, but massive MIMO will help to us, instead of communicating the signal in all direction, to avoid the interference with the mobile user. Assume that this is a mobile user. The massive MIMO communication technique can provide the connectivity, wireless connectivity, very focusedly to the particular specific user. Whenever we do like that, for example, the second user wants to get a connection. So this base station can establish a connectivity to this. So this type of technology is called a massive MIMO. For that, why it is named as a massive is that the number of antennas, whichever things which you see here, it may be a 64 by 64 or m by n. Huge number of antennas may be required. Antenna in the sense here depends on a frequency, the size of the antenna may vary. So for that, a separate technology is being formulated, which is being incorporated in the 5G. Because of all these technologies, the 5G is going to help. And another important things are beam forming technique, mobile millimeter wave. It's called. There are frequency ranges. In the forthcoming slides, we will see that. Mobile millimeter wave. The concept actually is being implemented by using a beam forming. This is called a signal processing technique. By using that, we can steer the beam from one user to the another user. If the person is start moving from here to here, the beam also has to move. So for that, the beam forming algorithms have been implemented. So these are all 5 key technologies is very important to understand the 5G. Some of the evolution, how the 5G has come, how it is evolved. Some key points. The mobile has made a leap every 10 years approximately. You can see 1980s analog devices. So you can see the AMPS, TACs. These are all the devices came analog based 1980s. That's called 1G. 1990s, digital voice. In 1980s, all our voice was communicated using analog sense. So in 1990s, from 2G onwards, our voice is being converted into digital. Digital modulation schemes have been incorporated. Currently, we are in our mobile phone, the basic mobile phone the classic type mobile phone, which is running based on 2G. So which follows the GSM and 2.5G onwards and 3G all are following CDM. So all these things are a technology which is formulated from the physical layer itself. So there are OSI layer. So you can explore that. I didn't include here OSI, Open System Interconnect. So it may have the 7 layers. So physical layer is in the bottom. The top layer is called application layer. All these things are virtual layers. So the physical layer, all the hardware related orientations and hardware algorithm, coding schemes which corresponds to the physical layer, it comes here in a physical layer. Application layer will be in a top layer, which is creating an app applications. So electrical engineers, electronics and communication engineer, computational engineers, they used to work here. There are 7 layers like this. So application layer, the CSE, computer science engineering students, they will normally work in the application layer from top to bottom. They used to proceed. Okay. So why I'm connecting all those things is that we need to have a macro level picture on understanding all those. And when it comes to the 4G level, mobile broadband, LTE and currently LTE advanced. Now from 2020s onwards, the wireless edge device is called 5G NR, new radio. So now we are going to talk about this 5G only. Okay. The 5G foundation started long ago. The foundational to 5G, the technologies used in each generation, 2G, 3G, 4G, everything is being utilized here in a 5G. The 5G, it's not formulated directly something new, no. Some of the key parameters which was used in the 2G is being taken here, that is also a part of this 5G. And in 3G, the low power computation algorithm or methods, the device to device proximity services, that key concept is being utilized to formulate a 5G. From the 4G, a cellular in unlicensed spectrum, how it is being utilized, and YFDM concepts, which is used already is in there in the 4G LTE. All these things are a foundation to get the 5G standards. Okay. Especially for this particular part, I will skip for this. The next one, expanding millimeter wave spectrum with the common framework, millimeter wave. So there are different frequency spectrums are available. You can see here 410 megahertz up to you can see the millimeter wave is coming at around 28 to and 39 gigahertz. So we are going to work in the 3 different domains. So the less than 6 or 7 gigahertz, it's a 1 band. So mostly cellular communication services, which is coming under that particular category. Very low frequency range is also available for a IoT, massive IoT data communications. That particular frequency can be used. And millimeter wave is actually 28, 39 gigahertz of high frequency ranges is being utilized for the purpose of massive communication, because all these frequencies are very important. Assume communication, especially in the case the message is the same. Say for example, to understand SPB voice, SP Balasubramaniam voice, a composed song. If you want to communicate, the same song can be played in an AM radio, FM radio, or in a cellular phone, or television, digital television, anything, anywhere. Message is still same. It is being shifted from a keyword is called a baseband to a passband. So shifting from one band to the another band is very important. Why? because the bandwidth, a device, a wired or wireless device which we are going to work on, that device should have that capacity to deal with this particular frequency. If the frequency is high, then wavelength is less. If wavelength is less, then automatically the signal cannot go beyond for a long certain range. So when we go for 28 gigahertz to or 39 gigahertz in that particular frequency ranges, the wavelength is very small, millimeter wave. So the signal can propagate very short distance, but at the same time it will have the huge bandwidth. That huge bandwidth is the benefit for us. So inside a room, I'm located in my home, where in my working table, I want to communicate something from one of my other device to here. Within a 1 TB of data, I want to transmit from here to there wirelessly. So I needed to go beyond that particular regional, locational domain. So geographically, if you see that when a device depends on the application, yeah. This is one scenario why we need a millimeter wave communication will be very helpful. Like that, many we will proceed further. What are the global researches on 5G and beyond? Some of the key words, key points. Areas of 5G research and development. 5G NR, LTE Advanced, Pro, 5G Spectrum. How to create a waveform, different types of waveforms. So my area is on signal processing and for communication, software defined radio. So majorly my explanations may be something related to signal processing with communication and networking perspective. And 5G private network and IoT, how to establish it. Cellular V2X. V2X nothing but vehicle to X to anything. From vehicle to any devices through wirelessly how to connect. Now see V2X, that's called a cellular V2X. That communication, how it can be established through a cellular network which is already available. So and 5G massive IoT. So these are all the major the research part is going on. So all of you can think in this dimension which area you want to work on. Currently the standard is already available. We need not to go and put the new algorithm for that, but that is also possible. But at the same time, if you want to create a new applications based on 5G, lot of openings are coming up now only. So it's a good time to explore more on this direction. So to get a lot of openings, you can capture that as for students. Now, who are all the global leaders in the 5G in R&D? Samsung, Huawei, ZTE Technologies Corporations, Nokia, Qualcomm, Verizon, AT&T, Cisco. So today's presentation, I have majorly referred from the Qualcomm reference materials. So the research areas in where in the different applications we can work on. E-health services, energy infrastructures, farming and smart city developments. Farming, you just will connect with the farming with the 5G, just will imagine this. How a farming can be improved by using a 5G technology. Both are contradictory, but still there are possibilities, huge possibilities are there, especially country like India. So the majority of our the income to the GDP growth, the contribution, the majorly is from farming. So and another one is called smart cities. So how to interconnect all the devices to make sure that the smart city implementation, so massive IoT can be used for that. Some of the spectrum allocations which is being done for the 5G, just I want to give you the idea, which is maybe fully based on the communication perspective, but very, very simple. We can easily understand because everybody, we are using the radio technologies. Without a cellular phone, we cannot. So less than 1 gigahertz. This is a one frequency band, and sub 6 gigahertz frequency band. And another frequency band is actually called 24 to 30 gigahertz. So these are all the frequency ranges actually it is possible to work on. At present, in our lab facility here, we can transmit and receive any signal up to the frequency range of 1 to 6 gigahertz. So your voice, if you want to communicate by using a 5G waveform, write a code, write a program, connect with the hardware, that program will speak with a radio, software radio, then you can transmit a signal through the space, receive it, and do the reverse operations also. Communicate and receive it is possible. So different frequencies is very important. So especially in the case of our India, here you can see 700 megahertz and 3.3 to 3.6 gigahertz, and the other 24.25 around 24 and 27 gigahertz ranges. So now you can understand why this 700 megahertz. I want to tell one more information here. Just more than 4 years, around 4 to 5 years, the central government have stopped all the analog televisions. It may be more than 5 years approximately. All the analog old our televisions at our home, hope you can see that your signals when we start doing the auto scanning from 450 megahertz to approximately 850 megahertz range, automatically it will start doing tuning. Now that tuning is not there because that particular frequency is being stopped, because all the television now it is becoming a digital television. This particular frequency band actually made to free for this purpose, especially in India, 700 megahertz plus or minus that particular frequency bands. 5G is going to utilize that. Okay. So 5G NR EMBB. I will give you some idea about what does it mean. 5G NR is a unified, more capable air interface. Different services, diverse spectrum, diverse deployments, different applications. Mission critical services where timing sense is very essential, very low delay, massive Internet of Things, enhanced mobile broadband. So I am talking about the research areas on 5G NR, new radio. So high frequency bands and middle band and low bands below 1 gigahertz. So here at present we can do any transmission and reception by using a facility of a hardware and software within this particular range. It's possible. So what is the main advantage of this module is called the 10x decrease in the end-to-end latency comparing with the old 4G. Old in the sense that the currently available. The 10x experienced throughput. Throughput is relatively higher. Throughput in the sense, in the layman level, we can understand if I am sending 8-bit of information to the outside, I cannot simply transmit 8-bit. That 8-bit can be converted into by doing a packetizing, packaging. So then it will become a 64-bit, for example, to understand. So that 64-bit, when it is communicated wirelessly, the receiver will receive the 64, then it will understand, it will decode, then it will become another 8-bit. So that throughput itself can be improved like anything. The 3x spectrum efficiency. For a given bandwidth, how much amount of the bandwidth can be utilized for the data communication. 3 times is increased. 100x traffic capacity. So more amount of data it can carry. That's the meaning. 100x, 100 times. Network efficiency is also increased. 10x of connection density. So because of the currently available 4G, so I am talking with you, all of you. I am having a connectivity. Assume that sometimes through a mobile 4G LTE connectivity, I used to interact with the students. That 4G LTE is helping me to do a video streaming very comfortably. So that is fine. But when it comes to the case of the huge amount of application which I was mentioning there, we may require the huge capacity of the network. That's why 5G needed. 5G will address the insatiable demand for a mobile broadband over a 60x growth in a mobile data traffic from 2013 to 2024. Now we are in 2022. So just will imagine we are badly in need of 5G. So knowingly or unknowingly, because it is transitioning, we may not be aware, yes, something is going up. All our devices will give a guidelines to what to do, what we need to do that. Next, the 5G is essential for next generation mobile experiences like media and entertainment applications. So rich generated data, every users are generating a high quality pixels. You can see that new mobile phones are having a 15 MB megapixels or 20 megapixels like that. So every photo image, if you want to send it to through network, you just will imagine the high quality data is being produced, but it is to be communicated. So the congested environment where the auditorium like environment. So where a heavy crowd will be there, only one base station which is being located there may not be having capacity more than a 20,000 users or members, audience in the football or cricket ground. So for them we need to provide solutions. The high speed mobility, you can see the background. So the vehicles are moving very high speed. Connected cloud computing. So the in office environment currently the work from home is actually is based on the cloud computing. Majorly the software industry people they are working from home based on this the success of cloud computing. So immersive experiences now the Facebook is being shifted from Facebook to Meta. It is actually is going to give the AR, augmented reality, virtual reality. It's incorporated with the social networking. So and connected vehicles. These are all the applications that augmented reality part. To do all those, when every users are having this facility, the currently available modules may not be helpful. And another perspective is an industrial perspective. If you see, enabler of the factory. In a factory, all the devices, machineries, everything is got connected. So if you want to check the condition of the machines, so continuously you want to do a monitoring. So we may require industrial IoT. So massive IoT. We may require the huge the data production will be there. It has to be communicated wirelessly like that. So for a safer autonomous transportation, which already I have mentioned, a person start moving, the car is coming, autonomous car, no driver. It has to detect if any person comes, immediately it has to apply brake. Everything's to be done within a period of 1 millisecond of a time. Ultra reliable, low latency. And reliable access to remote healthcare, precision agriculture, and efficient use of energy and utilities, private networks for logistics and enterprise industrial applications, sustainable smart cities, digitized logistics and retail applications. Providing ubiquitous coverage and essential services that complement the 5G NR. So whatever things which I have told as of now, now you can see here, initially I was talking about LTE. The extended version of current LTE into LTE Advanced Pro and 5G, you can see that, which can utilize the frequency range of relatively low frequency in terms of sub 6 gigahertz ranges. I think it is coming under the case of sub 6 gigahertz. So even within that range of frequencies, we can work on for the different applications. You see this existing LTE applications can be extended to the 5G, gigabit LTE, VO LTE, LTE IoT, automotive C-V2X, private LTE, digital broadcasting, all these applications. It's called ubiquitous, so it's there in everywhere. Ubiquitous LTE. Then very focused domain or area in a particular region, the new 5G NR sub 6 gigahertz frequency ranges, LTE coverage. So will be a regional area for cellular services may be available within 5 kilometers of circular area, and smart cities area and cellular services. This is in the playground. So here the frequency ranges of up to 6 gigahertz, it's fine. And the data rate also can be relative to the currently available 4G data rate, it's enough. In addition to that, more number of users, if they want to communicate, that's the problem. So that 5G NR is providing the solutions. New 5G NR millimeter wave, just will think on within a building, within a short distance of within one apartment or somewhere. If you want to do a 10 gigahertz of a 10 n into 10 GB, 1 GB, 10 GB, in terms of terabit of a data communication, if you want to communicate from a short distance, for a implementation of a short distance, millimeter wave, because the frequency will be into around in terms of 28 gigahertz, 25 gigahertz, that range. So for the application here, the frequency of the device must change, and the terminologies, the technologies which we have discussed earlier, everything has to be adaptively has to be changed. I cannot use the 3 different devices. If I am shifting from here to here, I cannot use the another device. Same device, it may have a gigabit LTE. When I am moving towards to this particular region, the device must have the compatibility to work in this region also. If I am shifting from here to once again to the millimeter wave range, still that device should have a capacity to provide the facility over there. So that's why the adaptability, the scalable parameters has been introduced in the 5G NR. Yeah, that's why the scalable OFDM based 5G NR air interface, which already I talked about, OFDM, orthogonal frequency division. Each information will be carried by the one subcarrier. It's called multi-carrier communication. So frequency localization, the windowing technique. So currently, the very recently the 5G is being banned in the some of the airports in US. They stopped it because of the leakages which happened, the spectral leakages which happened, which is actually affecting some of the other devices. That is actually is being handled technically. I think they have made some resolution on that. So they found some solutions for that also. So the reason behind is that it's because of a proper windowing technique. It is purely signal processing method, which is providing a solution without making much changes in the hardware. A signal processing technique can provide a solutions for that. A lower power consumption, and how to reduce the power consumption for each and every applications. So that is actually is being incorporated here, and which I was talking here earlier. the scalable 5G, the outdoor macro coverages, the outdoor macro and small cell communication. You see the total bandwidth and the architecture of each bandwidth also is changing according to the frequency ranges. So a common 5G platform will provide the facility to tackle everything. So this is about scalable parameters which I was talking. The scalable 5G NR slot duration, the latency. Okay. 5G NR optimized design for a massive MIMO. I gave enough outline on that. Here, the very important point is that there are two links will be there from mobile phone to the base station. It's called uplink. From the base station to the downwards to the mobile phone, it's called downlink. That frequency ranges will be different. There are technologies being involved to tackle the situations. Then 5G NR massive MIMO increases the capacity. You can see that the real images which was taken by the Qualcomm. I have taken from the Qualcomm reference materials. So that they have done implementation in real time. You see, as per the currently available facility, when it is being implemented into 5G NR massive MIMO, current communication system has a 52 Mbps. After implementing into a 5G, it became around approximately 204 times the data rate has been improved. So cell edge, it's communication. So all these things are approximately 3 to 4 times of data rate can be improved. These are all some proof to experimental results and simulation results which they have reported in the publications. So Tokyo simulation, it tested in the Tokyo environment, in the Tokyo city, 4G device in a 4G network, 4G device after 5G is deployed, 5G device in 5G network. When it comes to the 5G network, you see how much approximately 4x, approximately 4 time, approximately 13x time. You just will see that uplink and downlink, DL means downlink, UL means uplink. So for different terminologies is being tested in multiple locations. Then the standard has come. Then now the product is available. Millimeter wave. Before here, I want to talk one information here in this case of in Indian region, high level forum submitted a 5G recommendations to the government. Some of the research facilities is being initiated for the test bed. IIT Madras, IIT Kanpur, IISc Bangalore, and IIT Hyderabad. All these institutes combined with Geo and many technical industrial collaborations, they have established the 5G test bed. Now they are going to for testing facility. Once the testing, especially in the case of in India, if it works successfully, so they will go for the live implementation of the 5G. So now currently the Digital India scheme is actually encouraging developing our own indigenous technologies if it is possible to reduce the dependency of our technology from the other countries. But there is no other go here. We need to have some sort of, but at the same time, we can reduce the dependency part. So that is possible on this area. Then 5G global rollout, where it was implemented in different countries, that is being by the different companies. In that is represented here in India. Qatar is actually, they got, I think, some approval for implementing the 5G network over here. There are two classes are there, 5G sub 6 gigahertz. Something is written here in the blue colored, blue with 5G, sub 6 plus millimeter wave. So millimeter wave is implemented in Russia, and you see here in Romania and in Japan, they have tested millimeter wave combined with the 5G. So this is the public network access which I was talking about, the factory environment, public network, massive IoT, and private networks, indoor auditorium case, and yeah. So this already I talked about LTE Advanced Pro, gigabit LTE, DVO LTE, and combining LTE Advanced Pro, which will provide the enhancement of the existing 4G into a 5G module. So LTE IoT, eMTC plus NB IoT combinedly, all these things can be incorporated to the 5G framework. Yeah, this is the currently available LTE is continuing to the 5G environment. What are the terminologies, especially in the cases currently digital TV, public safety, LTE spectrum sharing applications, especially for cognitive radio applications. All these technologies, it must be executable or very limited changes or the same way how it works, that must be compatible when it comes to the 5G also. So that type of continuation is there in an evolution of this 5G environment. This already I talked about. So here C-V2X, vehicle to vehicle, vehicle to infrastructure, vehicle to pedestrian, vehicle to network. Combining all together is called V2X. That we can establish the networking by using a 5G environment. And this is extension of the 5G. I want to add some more point. That's why I'm skipping some of the slides over here, which already I have discussed. Another one is called the drone communication. So there are some standards are coming in 5G. We need to have a separate systems. The drone environment and communication channel also will have a provisions. There is a wireless communication will be connect with the base station. Continuous streaming will be done. Some releases being especially there in a release 15, optimize the LTE for drones. Applications of 5G, already I've told about industrial IoT, 5G NR, C-V2X, and future vehicles, shared or licensed spectrum. All our Wi-Fi devices, hotspot, all are unlicensed spectrum. Cellular phone, licensed spectrum. Cognitive radio means we can utilize unlicensed spectrum when it is not being utilized. For that, we may require software defined radio. This is the one layer of applications. The private networks, massive IoT, 5G broadcasting, millimeter wave evolution, sub 6 GHz evolution, and so one layer. The another layer is different devices, laptops, fixed wireless access, smartphones, even new device glasses like tethered XR, and automotive devices, automotive industries. And all these things can be incorporated with the artificial intelligence based, because the huge data will be available at the end where the data is being stored. So it is to be processed. Now that processing can be done. Everything is being done if it is in the server side. The problem is overloading the capacity of the server. So the problem to reduce that, the edge computing can be incorporated. So edge in the sense a cellular mobile phone is called a edge. Instead of sending all the information to the server, even the mobile phone itself, which can perform faster and which can communicate faster to the server, the load of the server can be reduced. So because of that also we can ensure the high throughput among client and server, especially for a distributed computing applications. Wireless edges, augmented reality, especially for the case of current Meta, Facebook, currently it's named as a Meta, may require all these facilities. The cloud-centric AI and fully distributed AI and partially distributed AI, artificial intelligence. So we need to have some sort of analysis on captured data. So data analytics after 5G is a huge market. Now designing into 5G, I'm sorry, a little bit the same information. So just you can see the scenario over here, vehicle to vehicle, one vehicle to the another vehicle, how it communication happens. And one vehicle to the base station, there will be a base station in the nearby pathway. It's called a vehicle to infrastructure communication, V2I. And vehicle to network, it need to connect with the base station where it is currently available. That's called vehicle to network. If a communication protocol which will help to realize everything, then it's called V2X. To realize this, see V2X, cellular V2X can be used, which is the another part of the 5G. So the same thing which we discussed, V2X. So future vehicles are coming like electric vehicles, e-vehicles. Most probably the future generation vehicles will have all these facilities. So this is the overview of what we have discussed earlier. I tried to reduce the technical aspects, then reduce the technical parameters. Mostly I tried to cover based on the graphical way of understanding. Some of the facilities available in our university here, hardware facilities, Universal Software Radio Peripheral, USRP, USRP X series, USRP N series, multiple modules are available. By using this one, you can write a code, a program, you can transmit a signal, you can receive the signal. For example, here there is an antenna, you can connect, you can receive it, you can transmit, you can receive any devices like MIMO. If we have 4 units like this, then we can have a 8 by 8 transmitter, 8 receiver unit. That can be done like that. There is another series is called USRP N series. Like softwares, National Instruments communication system shoot, and GNU radio is another software environment. All these things are programming tool. We may require a LabVIEW, a programming module, LabVIEW here, and GNU radio fully based on Python. You can Python, C++ modules can be used. MATLAB is the complete suite is available. So all these environment can be used to program our logic. Many of the already library logics are available on 5G. Connect with this, then you can transmit, receive, especially in the case of a 5G communication is possible within a given very short duration of a time. It is possible. Your voice can be communicated by using this environment in the 5G protocol, transmit, receive, and you can test it. So that facility is available here. And what all the job openings are available? Just I will connect here any one. If you click it simply, I have typed 22,771 5G openings are available. If I click this, you can see here nakurai.com. It's one of the famous job search tool. You can see there senior software engineer for LTE 3GPP with the knowledge of 4G. Then architect. So they may ask about some of the experience, 7 years or 2 years. There are some freshers they will invite. Why I'm asking is that more experience. So even if you are joining into some other industry, so we need to have a knowledge base on 5G. So that only will help us to explore more on. And another LinkedIn profile, if you see, through LinkedIn, if you check that, how many openings are there? 4G, 5G, 5G RAN. All these things can be realized, and we can explore more, and that knowledge base you can show there when you go for a job market. And Indeed and Nokia carrier site also. This you can search it in the different network. And another important point which I want to, the strong alumni network. There is a website is available, amrita.edu.again. So I have connected here. So students, those who are joining here, they can log into this. 20,000 Amritians are there. Means the students, those who have studied in Amrita, currently they are working in different part of the world. So by clicking this Amritians, you can search 20,000 members where currently they are working on, especially here. If you check the alumni map, you can see the Google map here. Amrita alumni are there all over the world. To get a proof here, you can see this, where currently they are working on. They have spread it all over the world. It is in Indian region. Currently, I am located here in Coimbatore. So, for example, if you want to do some research on some universities, either in the region of Denmark, United Kingdom, or US, by clicking there, you can get the idea about who are all they, where currently they are working on. All these people got connected through a professional network like LinkedIn and your own Facebook account. So when you are creating an account after joining in Amrita, if you can also be a member of this, then you can get a connectivity. So the success of the big universities like in IITs and NITs is like equally, the Amrita has a very big strength in alumni that through this you can get it. And the job openings, if any openings are there, so alumni members, they used to upload here referral information that won't be available in the another job portal. Here you can see, and you can request them to provide the recommendation for you. Then you can easily get into according to your research area. Yes, so lot of openings are available, and you can make use of everything. So that's all from my side. Thank you all.
Thank you so much, sir. That was a really good session, which was really informative for the students. So you have covered all the regions in and around 5G and also the applications, the job opportunities. So everything is covered. So I'm sure that the students have loved the session. So thank you so much once again, and thank you everyone for joining us for Saturday series. We'll see you all next Saturday. Till then, good day.